Hello students, welcome to Sarasa classes. We will be doing the CX disconnections of alcohols, ethers and sulfides. So out here basically our target material looks something like this, which is called RX. We disconnect over this bond, giving us R plus, X minus, and the synth forms for this can be written as RBr, ROTS, or ROMS, and X can be written as, so this is basically R plus, and this is my, for X can be written as XH. So now keeping ROH, okay, how to convert alcohols to RBr, then one can use PBr3 and that will give us RBr. Basically converting here alcohol to a very good leaving group. So if you are treating with methyl chloride in presence of triethylamine, which is the catalytic amount of base to remove the HCl formed as a byproduct, so we are going to get ROMS. And similarly, if you are using tosyl chloride, that too in presence of catalytic amount of pyridine, we are going to get ROTS. So OH is a bad leaving group. To convert OH into a good leaving group, we can replace OH by Br or OMS or by OTS. Now, aliphatic compounds that can be derived or made from alcohol. What are these? So if you convert ROH either to RBr or ROTS or ROMS, I am collectively writing this as RX. Now this RX, where X being a very good leaving group in presence of another alcohol and base, will undergo Williamson ether synthesis to produce ether. So over here we will say this reaction over here, which I'm calling as 1, is basically Williamson ether synthesis. Similarly, a similar approach can be taken for preparation of thioethers. So over here if we have R prime SH, where SH being more acidic than OH, so even a use of a weak base can lead to the formation of a thioether. All right. Next, if we want to replace this X with any halide, okay, and make this as RHAL, that can also be possible. So if you're replacing any Cl, suppose with Ki, then we will call this as to be Finkelstein reaction. Or if you're replacing any Cl with F, then obviously that we will say is SWOT reaction. So these can be some of the methodologies. Some other derivatives can also be created by replacing R, that is, we can place a nitro group or azide group, so we will classify them as other derivatives, and we are calling this as nitro and azide. which can be replaced, which can replace the good leaving group X. Okay. Now, one primary point to note over here is, which is very fundamental, the methyl and primary alkyl derivatives, where R being the methyl and primary alkyl, they react via a SN2 mechanism. Okay, so powerful nucleophiles and non-polar solvent should be used. Okay, so this is a mechanistic fact that should be kept in mind. Whereas if your R is tertiary, so for tertiary compounds which react via SN1 mechanism, all right, going through formation of carbocation, okay, from what starting materials? It can be alcohols, isn't it? Tertiary alcohols in presence of hydride can give you the 3-degree carbocations or alkyl halides or alkenes. Now this can be shown in a scheme. Besides that, one should remember that the solvent over here used is a polar solvent, okay, and a Lewis acid catalyst can also be used. To make a bad leaving group OH to a good leaving group. So, in a scheme wise, we can say now that we are having this type of an alkene. So, this is R1, this is R3. In presence of an acid, it will form the carbocation as I am showing. Okay, and that can also be produced from the alcohol. Okay, but we have to use a strong acid or a Lewis acid in presence of the acid. All right, and this can now combine with a halide X to form this type of a molecule. All right, this molecule can also be produced from alkyl bromides as I am showing over here. Okay, using a polar solvent, because polar solvents will favor the formation of this type of carbocations. Now, let us take an example of an analysis of a molecule for which we are going to do the retrosynthesis, something like that. So over here we are going to disconnect at this point, generating the pH minus and obviously the 3-degree carbocation over here, something like that. And for this particular synthon we will write out here, this is Cl, and this particular Cl can be further produced from this alcohol using PCl5 or SOCl2 or even concentrated HCl. So in the synthesis part, where we are trying to recreate this target molecule 3, we will consider the reaction of this particular tertiary alcohol in presence of concentrated HCl, and that will easily lead to the formation of the 3-degree alkyl halide, which when treated with benzene in presence of AlCl3 will lead to the formation of the target molecule 3, which is as shown. Thanks for listening. Keep visiting further for the extra approaches of molecules for disconnection. Keep visiting Sarasa classes. Thank you.